Hi everybody, welcome to this video where we look at the Grade 12 Maths Final 2023 Paper 1. In this one, we're having a look at question 1, which is on your algebra. Let us delve straight right into it with question 1. Question 1, we have x squared plus x minus 12 is equal to 0. This you should recognize as a quadratic equation because x is squared. To solve a quadratic equation, we have all of this components on one side of the equation and equate it to 0. From there, we can factorize. So we are looking for the factors of 12 that give us positive 1 when added or subtracted. So our factors of 12 are 1 times 12, 2 times 6, or 3 times 4. Those are all of your factors of 12. Can 1 and 12 ever give you plus 1 when added or subtracted? No, so those will not work out. Can 2 or 6 give you plus 1 when added or subtracted? Also, it is not possible, so those factors will not work out. So it has to be 3 and 4. So how can we get plus 1 from 3 and 4? We can say plus 4 minus 3 will give us 1. So then those are the factors that we will use. So we have that will factorize 2 brackets. Each of them will get x times x, because that's how we'll get the x squared. And then we add our factors of 12 plus 4 and minus 3. You can do a little check on the last term that when you multiply to get the same last term, so positive 4 times negative 3 is negative 12, so those do work out. Once we have the stage, we equate each of the factors to 0 to solve. So we have x is equal to negative 4, or x minus 3 is equal to 0, so x is equal to 3. So they are our two solutions for our quadratic equation. Let us have a look at the next question. For the next question, it's a quadratic equation again, and this time in brackets is answers correct to 2 decimal places. That usually indicates that you should use the formula, as in it will not factorize that well. So to use the quadratic formula, we have to equate everything to 0. So we take that 6 over and it becomes negative 6. Then the coefficients of x squared is our a in the formula. The coefficient of x is our b in the formula. And our constant term is the c in the formula. Please make sure that you are taking the values with the sign. The quadratic formula is x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. You get the quadratic formula from your formula sheet, so there's no need to remember it. However, you will need to know how to use it. So in this formula, we are then substituting in the place of minus b, we're putting what b is equal to, which is minus 2, plus or minus b squared again is minus 2 squared minus 4. A is 3 and c is minus 6 all over 2 times 3. We can simplify this further if you'd like. So minus 2 times 2, negative 2 is 2, plus or minus the square root of minus 2 squared is 4, minus 4 times 3 times minus 6 is plus 72, all over 6. So to get our two solutions, one will be the positive answer and the other will be the negative. So our one solution will be x is equal to 2 plus the square root of 76 all over 6, which rounded off to 2 decimal places is 1.79. Or the second solution will be the negative answer, which would be minus the square root of 76 over 6, which will give us negative 1.17 rounded off to 2 rounded off to 2 decimal places. Okay, so that's the quadratic formula, and that's what you need to remember. Let us have a look at the next equation. So the next equation has a square root in it. So to solve for x, we're going to have to square both sides. So first of all, we want to get the square root by itself, which it is, and then we can square both sides. So that and squaring that. So the square cancels out with the square root to give us 2x plus 1. And x minus 1 squared, be careful, this is a common mistake. It's x squared minus 2x plus 1. Do not forget that this is x minus 1 times x minus 1, which means you'll get a middle term. Now this goes into a quadratic equation, which we can solve by equating one side to 0. So 2x minus that 2x is minus 4x, and 1 minus that 1 makes 0. We have this a quadratic equation, and the best way to solve it is to factorize. They have a common x. Taking out the common x, you get that the factors are 0 and x minus 4. So that means x is equal to 0, or x minus 4 is equal to 0, which means x is equal to 4. Now, very often students stop at this point. However, you have to remember when you've squared both sides, you have to check that each answer is valid. You check the answer is valid by comparing the left-hand side of the equation to the right-hand side for each of the values. So let us do the comparison for x equals 0. The left-hand side of the equation is the square root of 2, substituting 0 in the place of x plus 1, which is the square root of 1, which is plus or minus 1. The right-hand side is 0 minus 1. So it is minus 1. Here we have that the left-hand side is equal to the right-hand side, therefore it is a valid solution. That is for x is equal to 0. For x is equal to 4, we also have to check that it's valid. So substituting 4 into the right-hand side, into the left-hand side, we get 2 times 4 plus 1, which is the square root of 9, which we get plus or minus 3. And the right-hand side is 4 minus 1, which is 3. And again, we have that the left-hand side is equal to the right-hand side, therefore your answer is valid. It is very important to check the validity of your answers when squaring both sides, as marks are allocated for that. The next question we have is an inequality. It's a quadratic inequality. To solve a quadratic inequality, we follow the same steps as we make one side equal 0. So I'm taking the 2x over. You factorize your quadratic equation. So here we are looking for the factors of 3 that give us minus 2. So it's minus 3 and plus 1. And then we get our critical values from solving this. So x minus 3 is equal to 0. So our one critical value is x is equal to 3, and x plus 1 is equal to 0. So our next one is x minus 1. To then solve the inequality, we're just going to do a simple plot. So we're putting our critical values. We have minus 1 and 3. This is a positive parabola because the coefficient of x squared is positive. So we'll put it through like that. And we are looking for where it is greater than 0. So greater than 0 is positive. So it's this region over here and this region over here. The values of x corresponding with this is x less than minus 1, and the values corresponding to this solution is x greater than 3. Please note that the value is excluded because it's a strict inequality, and that's the graphical representation of the solution. Next one is a simultaneous equation. So for a simultaneous equation, we first have to choose one to be the simpler equation and substitute the one into the other. So that's called the substitution method. So here for x plus 2 is equal to 2y, I'm going to take the 2 over and make x the subject, and that I will call equation 1. Equation 2 will be the second equation as is. And now what we're going to do is substitute equation 1 into equation 2. So every place that we see an x in this equation, we're going to place it with 2y minus 2. So this becomes 1 over 2y minus 2 plus 1 over y is equal to 1. So all we've done is we've replaced x with 2y minus 2. Now we'll solve this equation. So this here is an algebraic fraction, so we have to get the LCD and multiply through. The LCD in this case is 2y minus 2 times y. The first term is already over 2y minus 2, so we're just going to multiply the 1 by y. The second term is already over y, so we'll just have to multiply by the second component, which is 2y minus 2. The 1 on the other side is over 1, and that has none of the components of the LCD, so we'll have to multiply it by both. Then solving for this, we distribute that y into both of the terms. That 1 just multiplied makes it the same. So we have 3y minus 2 is equal to 2y squared minus 2y. This here is a quadratic equation, so we take everything over to one side. So we have 2y squared minus 5y minus 2, positive 2 when we take it over actually. And now we're going to factorize. We're factorizing, and in this case, we're factorizing when y squared has a coefficient and the last term. So the factors of 2y are 2y and y for the first term, 2y squared. The factors are 2y and y. And then the factors for 2, it's 2 and 1. It's a prime number. So we cross multiply 2y, and y times 2 is 2y, and we're looking for a middle term of 5y minus 5y. Can 2y and 2y give us 5y? It cannot, so these factors won't work. What we can do is swap one pair, so we swap the 1 and the 2, so that gives us y, and that gives us 4y. Now it is possible to get 5y, negative 5y if we have minus 4y and minus y. So we put that over there and that sign over there. So here are our factors. It is 2y minus 1 times y minus 2. So our solutions are 2y minus 1 is equal to 0, which means y is equal to a half, or y minus 2 is equal to 0, which means y is equal to 2. Now that is solving for one variable. We have to substitute it back in and solve for the other. So we need to substitute each one in. So substitute y is equal to a half into, now we can resubstitute it into either equation 1 or 2, whichever one you prefer. Equation 1 gives us the easier one. So x is then equal to 2 times a half minus 2, which is 2 times a half is 1 minus 2, giving us that x is negative 1. Our second one is we're substituting y is equal to 2 into 1. So we have x is equal to 2 times 2 minus 2, which is 4 minus 2, which gives us 2. So our two solutions are, for the x case, for this solution, minus 1 and a half. The x solution was minus 1 corresponding to the y half. And here we have 2 and 2. and that is the solution to this simultaneous equation. Okay. Let us have a look at the last question. Now, the last question tends to be a bit more tricky as it requires you to think a bit. So here we have that 2m plus 1 plus 2m is equal to 3n plus 2 minus 3n. And we have to determine the values of m plus n. So firstly, what we'd like to do is we would like to factorize because we don't like the pluses. So we can take out a common 2m between these two terms, leaving us to 2 to the power of 1 plus 1. And on the right-hand side, we can take out 3n as a common factor and have 3 squared minus 1. So let's simplify that. This is 2m, and 2 plus 1 is 3. And this is 3n, and this is 3 squared, which is 9 minus 1, which is 8. Now I'm going to write everything in its factorized form. So this is 2m times 3 to the power of 1, and that's 3, sorry, that should be n. Times 2 and 8, we can write as 2 to the power of 3. Now, what we'll do to solve is we'll equate the bases of 2 with each other and the bases of 3 with each other. So this here will give us that 2 to the power of m is equal to 2 to the power of 3. So m is equal to 3, and we'll get 3 to the power of 1 is equal to 3 to the power of n. So n is equal to 1. So finally, they would like the value of m plus n, and that's 3 plus 1, which is 4. So the trick in this one is to use the rules of exponents to solve the equation. When we're working with exponents, we work with our prime bases and to factorize and have multiplication, and that's what we've done to simplify. And finally, we've equated the bases with each other to solve for m and n respectively. So this is question 1 in paper 1. It is on the algebra. If you've struggled with any of the concepts that we've covered, whether it is quadratic equations, inequalities, simultaneous equations, exponents, please watch our detailed videos going through each of the processes. Thank you for watching. Bye.